my name's Hung. I'll be talking about rapid forgetting prevented by retrospective attention cues. Let's get into it. I'm a pretty forgetful person, you know? Like I'll forget something right as I walk out the door and I won't even know what it was that I was supposed to remember. So I'm looking at my next assignment coming up, which is this one, and I knew exactly what I had to do. So the study I'm looking at is a 2013 preventative study of rapid forgetting based on retrospective attention cues conducted by Pertsov and friends. The aim of the study was to test if attention directed to an item already in short-term memory, which is the retrospective cue, can protect it from rapid forgetting. If so, this implies that attention is significantly correlated to maintaining a high-fidelity memory representation, which is valuable as it distinguishes between passive memory decay and attention-dependent memory in the working memory. Essentially, this shows that active attention can preserve precise memory for prioritized items. What was that? Did I hear you ask how it was done? Well, I don't care if you ask or not, because I'm going to tell you anyway. And because I can do what I want, I'm going to pretend that me and you are the participants. So imagine we are sat down, right? And we are presented a brief array of simple oriented bars presented at different distinct locations. And after each array is presented, our memory was held over a short interval. After which, an internal retro cue then indicated to us which previously seen bar would be tested. This retro cue basically just pointed out to us the location of which item was about to be tested. As you can imagine, this would theoretically allow our attention to be redirected and recall the specific memory representation. Alright. Slow down. You sucked. You were a terrible participant, so get out of here. Anyway, the timing between array offset and the retro cue, as well as the timing between the retro cue and memory test, were varied across trials to see how active attention affects memory decay. In valid retro cue trials, the indicated item was the one later tested, and in neutral no cue trials, there were no informative cues given before the test. In the test itself, a probe with an adjustable bar was shown, and participants were told to match the orientation as closely as possible. Once done, performance data was quantified as the angular error between the participants' reported orientation and true orientation. So the orientation it was actually supposed to be at. These errors were then further decomposed with a mixture modeling to estimate memory precision, SOP errors, and reporting a non-existent cue, and random guesses. I know, you were dying to know what the results were. And since you asked so nicely, I will tell you. To start, clear evidence was found that retrospective attention protects short-term memory from rapid memory decay. The baseline, or no-cue conditions, showed that accuracy declined with longer delays, seen in larger angular errors and increased guess and swap rates. This basically indicates rapid time-dependent loss of fidelity. But when participants were given a retro cue, where the baseline showed a deterioration, the retro cue's condition, accuracy, was largely preserved across comparable delays. Subsequent mixture model analyses confirmed this, along with a reduction of both guess and swap rates. These results demonstrated that active, directed attention can maintain a high fidelity memory for prioritized information, effective across elapsed time. As amazing as this is, of course, there are limitations. The study was limited by simple visual features, simple bars oriented in a specific direction, and the delays to test memory retention were short. The retro cues are also highly valid, which can't always be replicable or representative in real-world situations. It was also identified that the samples and simple tasks may not be generalizable to more complex, multifaceted studies. And arguably most importantly, there were no neural measures, leaving the underlying physiological mechanisms unobserved and non-causational. But on a better note, the study itself included a causal manipulation of internal attention that identified causal relationship between such and short-term memory. The study also included the aforementioned model-based decomposition that separated precision from swap and guess answers, as well as a sensitive continuous report paradigm that captured fine-grained errors. All in all, these findings imply that short-term memory is not just a linear decay, but is dynamically governed by factors such as internal attention that can selectively stabilize prioritized items. By suggesting that rapid memory decay can be diminished by timely cues that reorient attention to items, this study also further supports priority-based models of working memory over fixed slot and decay-driven models. In practice, this study bolsters interface designs and clinical strategies that leverage similar retrocue prompts to protect key information and can guide future research to test and identify neural mechanisms that implement this attentional protection. Thank you.